Okay, good evening, good evening, good evening to everybody. Superb. Nice to see you all here in this wonderful evening session. Yes, good evening, everybody. Perfect. Okay, so today we are going to, okay, let's start with our rituals. Okay, let's announce, the successful people for the week who have completed green belt or black belt this week. And then we welcome the new people in the community, and then we'll start the session. Okay, so let me announce the names for this week. I have 3 participants who have completed their certification this week. There are 2 green belt and 1 black belt. Okay, so join hands together, congratulating. First one is Mr. Abhishek Anthony James. Okay, everybody congratulate Mr. Abhishek James in the chat box. Are you here, Mr. Abhishek? If you are there, just give me a thumbs up in the chat box. Abhishek Anthony James. Congratulations. Super. So he has completed his green belt certification successfully. Okay. And the second one is Mr. Sunil Kumar Ram. Okay. Mr. Sunil Kumar Ram, congratulations. Mr. Sunil Kumar, congratulations on completing your green belt certification. Okay. Good. Everybody congratulate them. Again, this is all their congratulations and your motivation as well. Okay. And the one who has finished the black belt certification successfully this week is Mr. Ajay Tiwari. Mr. Ajay Tiwari. Everybody congratulate Mr. Ajay Tiwari in the chat box. He has completed his black belt certification this week. Okay. Superb. So congratulations, gentlemen. Mr. Abhishek, Mr. Sunil, and Mr. Ajay on completing successfully your green and black belt certificate. Okay, great, fantastic. All right, who are the new people today joining first time? Just type me in the chat box. Just type me in the chat box that you are the first time joining here in the live session. Okay, Paurush is there. Okay, who else? Who will just type me in the chat box quickly? Quickly, let's see. A lot of people are yet to join because we only have almost close to 60 people right now. Yes, who else? Just type me in the chat box quickly. Chalo. Okay, nobody else? The new koi bhi nahi aaj? Okay, very good. I think yet to join people. Huh? All right, so everybody just welcome Mr. Paurush and everyone else who will join later, who are the new participants. Okay, fantastic. So for the new people, it goes like this. We take up a topic which is important for our Lean Six Sigma understanding. Okay, we go deeper, we go practical. We do minute-app exercises. We have the question answer directly. Okay, that happens at the end of the session. Okay, so the first part, 75% of the session goes for the topic, and then you can ask the question. That question might be for the topic, might be for something something which you have any challenge while studying as well. You can ask the question. Okay, now yeah. So what is today's topic? What are we going to discuss today? Yes, exactly. Now when we are actually learning Lean Six Sigma, okay, so understanding Sigma is very important, correct? See, because we have our Minitap software, etc., which you feed the data, it will give you everything, right? It will give you what is mean, what is mode, what is median, what is standard deviation, what is variance, what is this, what is that, everything it will calculate. But for us, our basic understanding should be very clear. Okay, that's what I have decided that we will decode the formula of standard deviation. Okay, because this is the best way you can understand what is standard deviation, and then after that, because when the formula is decoded, how that formula is arrived, once that is decoded, then it will be very easier for you to understand standard deviation, and then going ahead, how to utilize standard deviation in different what you can say scenarios that we are going to discuss. Okay, now. So let me go to my whiteboard and immediately jump onto the topic. We're going to discuss about standard deviation, okay, which is sigma. We are going to discuss about standard deviation, or which is sigma, right? Sigma. So which is denoted by this letter, right? Greek letter, which a little 6, which is kind of horizontal 6. Okay, looking figure, right? So what is standard deviation? So before we understand this, let's understand some of the basic fundamentals of Lean Six Sigma. Okay. Now, Lean Six Sigma, if you really see, okay, we see Lean Six Sigma is a complex problem-solving methodology. Everybody knows this. Just type yes in the chat box. Everybody, it is the problem. So we solve the problem, right? Through projects, we solve the problem, right? Complex problems. Everybody knows this. Just type yes in the chat box. Yes. Super. So just a second. I think. Okay. So now, in reality, what happens here is, so we have a real life complex problem. Okay, so we have a real life problem. What do you mean by real life problem? What do you mean by real life problem? Which means, let's say you have a customer complaint coming back again and again. Okay, recurring customer complaints, a real life challenge. A machine which breaks down continuously. The average call handling time is very high. The lead time of delivering, developing a software is very high, right? The inventory is very. So we have, these are the real life problem, real life challenges we are facing in our processes. Okay. So what we do, we convert real life problem into statistical problem. Write this down. Statistical problem. Okay. How do we do that? Yes, not achieving the agreed output. Absolutely right. So how do we define a problem? So there is a what you can say, outcome which we are expecting, but we are not achieving that. So there is a problem. There is a gap. There is a problem. Okay. So real life problem we convert into statistical problem by collecting the data. Understand this. So we collect the data and we convert that problem, the real life challenge, into statistical. How do we do that? For example, let's say there is a machine which breaks down. So we'll collect all the breakdown data of that machine for last 1 year or 6 months, whatever it is, right? So by collecting the data, what we are doing, the machine breakdown problem, we are just converting to numbers. Now we know how much is your downtime per month, per week, per machine, whatever it is. So we are collecting the data and converting that into a statistical problem, correct? Then by using statistical tools, formulae, and principle, we are finding a statistical solution. Statistical what? Solution. Write this down. So real life problem converted into a statistical problem. Statistical problem by using statistical tools, principle, formulae, we convert that into statistical solution. Okay. And then we convert that solution into real life solution, and we implement it. And then what we do, we implement and we get the result. So in the nutshell, the define, measure, analyze, and improve, actually we are doing this thing. A real life challenge we are converting into statistical problem by collecting the data, and by using statistical tools we are finding out statistical solution on that, and by using statistical solution we are converting that into a real life solution. Okay, this is the summary of our DMAC, our structure of the DMAC framework. Everybody with me till now, just type yes in the chat box. Are you noting it down, or you can take a screenshot, whichever is convenient for you? Are you clear till now? Just type yes in the chat box. Yes, clear? Correct? So why this standard? See, I'm just giving you the background about standard deviation, because you should know why are we doing this? इसकी जरूरत क्या है? Right? तो ये जरूरत हम समझ रहे हैं. Why are we using this standard deviation? Clear है? Yes, very good, fantastic, very good. Okay. Now, any question you have, there are two options. You can ask the question in the chat box, okay, or write this down and ask it at the end of the session. At the end of the session, okay? Yes, clear. Very good, fantastic. Now, let me just quickly give you another fundamental. Look at this. Let's say this is a target. I'm just giving you a simple analogy. Just try to understand this. Okay, I'm giving you 3 scenarios. First, try to understand all the 3 scenarios, and then you have to give me the answer. Okay. Fantastic. So this is target, this is LSL, and this is USL. This is target, this is LSL, and this is USL. This is target, this is LSL, and this is USL. So this is first, this is second, and this is third scenario. Okay. Now, so this is no, nothing. So Madhvi, you can just take a screenshot of this. Just take a screenshot quickly. What we have discussed is real life problem. We convert into statistical problem by collecting the data, and we, by using the statistical principles and tools, softwares, we convert into statistical solution, and then we convert that statistical solution into real life solution. This is a summary of our DMAC framework. This is what we do. Okay. Our today's topic is standard deviation. That's what I'm giving some background. Okay. Now, what we need to do is, so let's understand this. Now you need to give me, now everybody's clear about LSL and USL. What is LSL? Just type in the chat box. Everybody, I want everybody to be clear about it. What is LSL? What is LSL? Lower specification limit. Fantastic. What is USL? It is upper specification limit. Clear hai? Everybody's clear about it. And target is where exactly we want to achieve. We want to hit it. Right? You remember that 9 o'clock office arrival time example I always give in the yellow belt session. Correct? So at 9 o'clock, do we reach? Everybody says no. There is always a variation. Correct? So because then our management gives us here, you know, the some specification limit. Okay, you have to come between 8:30 to 9:30. So we are given a range, correct? And that is called USL and LSL. Now you need to give me, I will give you 3 scenarios. Okay, let's understand this. I will give you 3 scenarios. Scenario number 1. Scenario number 2. Okay, now tell me. Now you tell me before I write down the scenario number 3. Is it a good process or a bad process? Process number 1. Is it a good process or a bad process? Just type your answer in the chat box. Good process or a bad process? Good process. Okay, few people are saying bad process. Now, why it is bad? Because, okay, why it is good? So this is, okay, so the area which I just made, you know, I just demarcated, this area is what? This area is what is this region called? Type in the chat box. Defect. Error. Everybody clear about this? Anything which goes beyond specification limit is a defect. Clear hai? All the new people. Okay? Yes. Anything which goes beyond. If you reach after 9:30, it is a defect. Correct? Out of specification. Okay? Defect. Rejected. It will be rejected by the customer. Correct? Now, what about process number 2? Is it good process or bad process? I'm not going to give you any judgment. Now, this is the mean of the process. For this is the mean. Is it a good process or a bad process? Type in the chat box. Bad process. Okay, is it a bad process? Okay. Two people are saying good process. Okay, very good. Now see here, the region which I am just denoting, this is, which region is this? This region which I have just denoted by the, is a defect region, because that is more than, process is not at the center. Very good. Very nice. Very nice. Okay. Now understand this. Now you tell me, what about this process? What about this process? Is it a good process or a bad process? Is it good, bad? Good process, or a perfect or a great process, or the best process, I would say. Yes. Now try to understand this. Try to understand all the scenarios. Okay. Now in the first process, the process is hitting the target. Process mean, okay, the X bar, which is the mean, the average, is hitting the target, but the variation is very high. The spread is very high. Are you understanding the first process? Just type yes in the chat box. It is hitting the target, but the spread is very high. Are you understanding this? Just type yes. Clear hai ye? Anybody has any challenge in understanding this? The process is centered, but spread is huge, and it is having, you know, it is taking defect on both these sides. Correct? Clear hai? Yeah. Avnish ji, you haven't understood? Yeah. Let me give you example on this so that you will understand it. Okay. So there is a process where the spread is very huge. So if you come across that specification limit, because of the spread, there are more probability of the data going out. For example, let's take the same example of office arrival. Okay. Now, अगर आप ऑफिस में पहुंचते हो 9 बजे का टारगेट है, so this is 9 o'clock, आपका टारगेट 9 o'clock है, and let's say 8:30 is our LSL and 9:30 is our USL. Okay, this is our scenario. So, but if I take the data of one person, that person sometimes come at 8 o'clock, sometimes come at 10 o'clock. Can you understand this? So this anything which is beyond 9:30 and before 8:30 is a defect. So a simple example I'm giving. Are you clear now? The spread is so huge. कभी कभी वो 8 बजे आता है, कभी कभी 10 बजे आता है. And specification is 8:30 to 9:30. So lot of data are beyond specification. Are you clear now? Avneet ji, are you clear with this? Yes? Just type yes in the chat box so that I get the confirmation. Okay, you said yes. Okay, very good, very good. Okay. Now, what about this process? Second process. Now try to understand this. First process, hitting the target, but huge variation. Second process, less variation, but not hitting the target. Are you understanding? It is way away from the target. You can see this target and the mean is lot of distance. Can you see here? So it is variation is very low. Okay, but off target. Are you understanding? Yes, just type yes in the chat box. First process and second process, both are not good processes. The process number 3, because it is hitting the target and it is having the less variation, it is the best process out of these 3 processes. Are you clear? Because the mean and the target is exactly matching and the variation is so low that there is very less chance of getting the out of specification product. Okay? Yes? So with this context, how will we define the quality? So quality is, write this down. Quality is, just try to understand this, hitting the target, and plus, I would say plus, reduce the variation. Understand this. So what is the quality product? Quality product is hitting the target all the time and reduce the variation as much as possible. If you are meeting both these criteria, that is called a quality product. Are you clear? Just type yes in the chat box. So what is the definition of the quality? Hitting the target and reducing the variation. Clear hai? Are you clear? Just type yes in the chat box. Okay. So both elements are very important. That's what I just wanted to drive, that both elements are very important. What are the both elements? The central value of the data, which is, the mean. We want to know the mean as well. And we want to know the variation as well. Are you understanding? Both are very, very important. That means, for example, if I have to write down here, okay, I will check the mean just to make sure the hitting the target, and variation, I will check standard deviation or sigma. So both these aspects are very important. Are you clear? Just type yes in the chat box. For hitting the target, I will check the mean, whether mean is exactly matching my target, and to check the variation, I will check sigma, standard deviation. Clear hai? Now you will connect the dots. Why this standard deviation is so important? Everybody clear about this? Just type yes in the chat box. Just type yes in the chat box. Clear, everybody, especially the new people. Okay? Yeah, especially Paurush. Are you clear about this, Mr. Paurush? Just type yes, even though you are the first timer. I'm just giving very fundamental thing. Yes, clear? Very good. Very nice. Very nice. I'm glad that you can connect with this. Okay? Very nice. Okay? It might be, if you are into the subject already, it will be very easy peasy for you. Okay? Okay, Ali, you're also first timer. Fantastic. Have you understood the concept till now? Simple, hitting the target, reducing the variation. Okay, very good. Fantastic. So that is what we are going to discuss about this standard deviation. Now, Okay. So standard deviation is a measure of variation. We all know that, correct? Okay, you have gone through this CPCPK, fantastic. So it was a little difficult topic to understand. Today's topic is very simple topic. Okay, today's is very basic fundamental topic. Now, standard deviation is a measure of variation. Okay, standard deviation is measure of variation. More the variation, more the standard deviation. Lesser the variation, lesser is the standard deviation. I repeat again. Now this process number 1, the standard deviation will be very high. It will be high. And process number 2 and 3 both, the standard deviation will be very low. Are you understanding? The spread of the data is defining the standard deviation. Are you clear? Just type yes in the chat box. More the spread, more the standard deviation. Lesser the spread, lesser the standard deviation. Very simple. Correct hai? Okay. Yes. Very good. Now let's calculate the standard deviation. How the standard deviation is calculated. Okay. Now we need not to calculate standard deviation ever by our hand, but we are decoding the formula of standard deviation so that you are completely fundamentally clear. Because when we are calling ourselves, I'm certified Lean Six Sigma, person, professional. So you should understand what is Sigma, how it is derived, what is the objective, what are the advantages of that, right? So to understand this, I'm going to decode today the formula of standard deviation. Okay, formula of standard deviation. Now let's do one thing. What I want, I want 5 volunteers. Okay, I want 5 volunteers and their heights in centimeters in the chat box. Okay, any 5 volunteers, write down your height in centimeters in the chat box, whatever is your height, if you know it. Okay, if you know this. No, don't write in feet and write in centimeters. Centimeter mein likho, 172, 16. Okay, I will take random numbers. Okay, and we will calculate the standard deviation of this. Okay, very good, very good. Then I will give you some analogy as well. Okay, so I'm writing 165. Okay, make a note of this. 165. I'm randomly writing 171, 175. Okay, 168, 168. And the 5th one, we will take something like 164. Okay, my God, Divakar, you are a very tall guy, huh? 184, fantastic. Okay, over 6 feet. Very nice, very nice. Super. So let's take these 5, 5 numbers. Okay, just to begin with. So the first one is, so what we're doing, we are step by step, we are taking the reading. Okay, now what does understand this? This reading is in centimeters. In centimeters. Okay. So what is the unit of standard deviation? Anybody knows about it? If I want to calculate the standard deviation of this, what will be the unit of standard deviation? Can you tell me? Okay, no unit. Unit of the main function. Very good, very good, very good. No unit. Okay, so few people are saying no unit, few people are saying same of the data. Very good, very good. So yeah, so standard deviation, always remember this, standard deviation has unit of the same function or the same data set what you have. So if data set in centimeter, your standard deviation will be in centimeter. If data set is in feet, if you would have taken a feet data, okay, 5 feet 3 inches, 6 feet 2 inches, etc., that will be into that feet. Okay, if it is in meters, that will be in meters. If it is in kilometers, that will be in kilometers. Try to understand this. Okay, everybody clear about this? So whatever is the unit of measurement of the data set, the standard deviation will have the same unit. Write this down. Everybody clear? So standard deviation also has a unit, and now we are going to decode this. Okay, we are going to what? Decode this. So first step of this is collect data. Collect data. Correct? So the step number 1 is collecting the data. Second step is find the mean of the data. Find the mean of the data. What is the mean? Mean is X bar, the average, okay, of the data. Can you just calculate quickly, pull out your calcs and just add these 5 numbers and divide them with 5. Tell me the number in the chat box quickly. We'll do it practically, okay? Once, okay, find the mean of the data, right, which is X bar. 172.6. Okay, 171.8 कैसे आ गया? दो कैसे आ गए? एक ही बार देखो, this is 165, 165, 171, 175, 168 and 184. Everybody just calculate it once again and give me the number. X bar is 1. Is it 172.6 or 171.8? Because I have got two answers. I'm confused. I don't want to pull out my calci now. Chalo, fatafat karo, fatafat. 120, 172.6. Okay, good. So I'm going with the majority. I'm not calculating it. Okay, 172.6. Are you understanding? Just type yes in the chat box. Okay, so what I've done, I've collected the data and I have just taken the mean of the data. Simple hai. Second step clear. I have collected the data. I have taken the mean. Clear. Third step. Calculate the deviation. Calculate deviation. What is deviation? What is the deviation? Deviation meaning. Okay, no problem. It happens. Okay. Yeah. So calculate deviation. What is deviation? Deviation meaning the distance from the mean. Distance from each and every data point from the mean is called deviation. Very simple. Okay, so my mean is 172.6. So my deviation will be, okay, so I will write the deviation in D1, D2, D3, D4 and D5. D is deviation. What does it mean? So D1 will be 165 minus 172.6. D2 will be, now if I have to arrange it in the ascending order, okay, I'm arranging it in ascending order. So 168 minus 172.6, okay. So this is first, this is second, then this will be third data, etc., etc. So I have arranged it in the ascending order. So D1 will be this, D2 will be this. So you give me D1, D2 number now. You give me D1, D2. Everybody clear about D1, D2? D1 is deviation. Okay. So you can arrange it in a ascending order. Okay. Let me arrange it. Let me arrange it for you. First will be 165. Second will be 168. Third will be 171. Fourth will be 175. Fifth will be 184. Okay. So this is our ascending order data. So iska D1, D2, D3 nikaliye. Yeah. So D1, D2, D3 is, so what I will do is, I will remove this. Okay. Let me just remove this data so that the confusion will not be there. Okay. Let me just a second. Just give me a second. I will remove this. So this is the data set. What is given? Okay. What I've done, I've just arranged the data set in the ascending order. 165, 168, 171. Okay. What is given? What is the distance of mean 172.6 from 165? That is called D1. What is the distance of D2, which is 168 minus 172.6? What is D3? 171 minus 172.6. Okay, clear? Yes. Now what I will do is, very good. So D1 is, everybody, minus 7.6 is D1. Minus 4.6 is D2. Very good. Minus 1.6 is D3. 2.4 is D4. And 11.4 is my D5. Everybody with me till now, just type yes in the chat box. D1, D2, D3, D4 and D5. Clear? Everybody just take yes. Anybody who has not understood this, ask the question. What we have done, we have collected the data, we have found the mean, and we have found the deviation, distance from each and every data from the mean. Clear hai everybody? Till now, so far so good. I don't want anybody to fall behind, okay, especially the new people. And I believe the new people are understanding it even more faster today. Okay, experienced people in the room right now. Okay, yeah, no worries. I will go very slowly. Okay, Sarvan, are you clear with till now? Just type yes in the chat box. Till now, very slow. Till now, very easy. Yes, clear. Okay, very good. Now, what we are going to do is, number 4 is, now understand this. Okay, for a layman's language. Okay, The standard deviation is nothing but the average distance from the mean. Just try to understand. It is not technically right definition, but from the mean value, what is the average distance of each and every data point? If I take all the distances and take the average of that, that is nothing but a standard deviation. Have you understood this? Just type yes in the chat box. Have you understood? Have you understood this? The variation from each and every data point, if I take the distance and take the average, that is nothing but standard deviation. It is a layman's understanding of standard deviation. But technically, there is a flaw in this. Okay. Technically, try to understand what I mean to say. See, it's very simple. Ankit, it's very simple. I take the mean. Mean is what? 172.6. Then we have taken, I will repeat again. I will try to understand this. The mean average is 172.6. Everybody understood this? Just type yes. Okay. Ankit and Mr. Abhik. Yeah, clear hai? Yes. Mean is 170. Now, from the mean, what is the distance of each and every data point? If I take, that is what the D1, D2, D3, D4 is all about. The distance 1, distance 2, distance and deviation. Distance is nothing but a deviation. Clear hai? Yes. Everybody clear? Yes. Very good. Very good. Now, if I take the average of these distances, it is standard deviation. Ideally, if I take the average from the mean, average distance of each and every data point, it is nothing but a standard deviation. Clear? Got it? Very good. Now, but in this understanding, there is a technical flaw. The technical flaw is because if you observe this, some of the values are negative, some of the values are positive. Are you understanding? 3 values are in negative side because they are lesser than the mean, and some values are positive because they are greater than the mean. Are you clear? Just type yes in the chat box. Okay? Yes. So left from the mean are the negative values because they are lesser than it, and right side of the mean, they are positive values because they are greater than the mean. Okay. Now, if I take the average of this, the negative and positive will clash with each other and they will not give me the right distance. Are you clear? Just type yes in the chat box. Are you understanding this? If I directly take the average, exactly, it will not give me the right result because the negative and positive will clash with each other. Okay. Yes. So what we are going to discuss here, what statisticians have done. Okay. Yes. Very good. Exactly. So what these brilliant statisticians have done, they have squared the distances. Okay. So they have done. So what you need to do is square the deviation. So the step number 4 is square the deviation. Why would we square this? Because square number is always a positive number. Remember this. Okay. Square number is always a positive number. What is square? 2. What is the square of 2? It's 4. What is the square of -2? It is also 4. Are you understanding? Are you clear? Why we have to square it? Square the deviation. Square the deviation because the squared value is always a positive value. Okay. So what we are going to do? D1 square, D2 square, D3 square, D4 square, and D5 square. Can you just quickly do that? Pull out your calcies. -7.6 square. Can you just give me the answer? -4.6 square, -1.6 square, 2.4 square, 11.4 square. Okay. And just give me all the 5 squared numbers in the sequence in the chat box. Okay, fantastic. You guys are amazing. Look at this. People have calculated. So it is like this. 57.76 is D1 square. Okay. Which is -7.6 ka square hai. Okay. Then the second D2 is 21.16. Third one is 2.56. Now I'm just going with you guys. Okay. I'm not doing calculation. I'm believing that, and because your calculation is matching, so I'm just taking the majority wala formula, simple. And then the next D4 square is 5.76 and D5 square is 129.96. What we have done, we have just taken the square of these values. Third step, the distances we have taken. So we have squared the value because square values are always positive. There is no negative value. Are you clear till now? Just type yes in the chat box. Are you clear till now? Clear, clear, clear. Everybody clear, clear. Just type yes, clear. Simple. I'm going very slow. Step number 4 is square the distances because negative and positive will clash with each other. To avoid the conflict, we are squaring the value. Okay. Now you take the average of this squared value. Okay. Step number 5 is now you take the average. So step number 5, take average of squared values which is d1 square plus d2 square plus d3 square plus d4 square plus d5 square divided by 5 because we have 5 data points with us. Can you calculate this quickly for me? Is it 43.44? Everybody take your time. Just add them up. Okay, we have already taken the square. Just add them up. 57.76 plus 21.16 plus this divided by 5. Okay, so the average value will be 43.44. Everybody got this value till now? Just type yes in the chat box. 43.44. Take your time. Okay, everybody is not very fast in calculation. Why I want you guys to do it manually? Because see, we have taken random heights from our team only, correct? So there was no data. We have just taken the data and we are just breaking down the step-by-step process. Okay, 43.44. Clear hai? Everybody got this? I will wait for it for 1 minute. Okay, take your 1 minute, add the 5 data points and divide it by 5. And yes, clear hai? 43.44. Yes, this value is called variance. What is that? Variance, which is denoted by sigma square. This value is called variance or sigma square. Look at this. Write this down. This value, what we have calculated, is called variance or sigma square. Sigma square or variance. Right? Now, because we have taken the squared values, okay, then what we will do? Now we will take the square root of this. Now we have to do square root of variance. Square root of variance, which is square root of sigma square, which is nothing but square root of 43.44. 43.44. Can you do it and give me the answer? This is called standard deviation. Sigma. Can you give me the answer? 6.59, is it? Okay, fantastic. Very nice. 6.59. Very good. So the formula is, if I have to summarize the formula of standard deviation, sigma, write this down, write that formula down, square root of summation of, write this down, T, okay, understand this, Tn square divided by n. Dn square. Dn is nothing but the distance from each and every data point. So the distance of each and every data point square we have taken, right? So summation of Dn square divided by n. N is equal to number of data points. So Dn meaning there are 5 distances. That's what it is called Dn, right? N is equal to 5. So divided by n is number of data points is 5. So the number is 6.59. 6.59. What is the unit? Centimeter. So this is 6.59 centimeter, and this is the formula of standard deviation. Are you clear? So now, are you clear step by step? All the 6 steps are clear. Let me revise it so that it will be complete. Yes, I will repeat all the steps one by one. Okay, clear hai? Yes, very good. So you are clear. I will repeat the steps so that anybody who is missing out will understand it. What we have done first, we have collected the data. I have randomly asked the 5 people height, and the height was 165, 168, 171, 175, and 184. Okay, so the lowest to the highest, we have the span. Okay, the height. Now, then the second step, what? So we have collected it. Step number 1, collect the data. Step number 2, we have taken the average of the data, which came out to be 172.6. Okay, step number 2 clear hai? Just type yes in the chat box. Step number 1, step number 2 clear, 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 clear. Just type clear. I'm just revising so that anybody who has not understood, you will clearly understand it. Okay. Now, step number 3, from the mean, we have found out the distance of each and every data point. That is called deviation. D1, D2, D3. Clear? So we have taken deviation, which is from 165, and 172. What is the distance? So which was minus 7.6. D2 was minus 4.6. D3 was minus 1.6. Okay, like that. So we have taken the distances of each and every data point from the mean. Okay, and because there are minus and plus, the negative and positive numbers. Okay, we cannot directly take the average because that average will not give the right answer. So to avoid that, what we have done, we have squared that distance, because squared value is always a positive value. That's what the step number 4, we have taken the square of the deviation. So the step number 4, we have taken square of the deviation. No, see, we can take, see, just for your clear understanding, I've just done the ascending order. Okay, you need not to do it in the real life. Real life, you put the data, it will calculate it. It will get calculated. Okay, just for your simple understanding, I've just put that in the ascending order. Okay, it's very simple. In the real life, you
So
need
I have a doubt.
yeah. Yes, Mr. Porus, tell me.
So instead of squaring the deviation, we can just like get rid of the negative number, right? Because it states that it will be on the left side of the axis, and the positive states that it will be right side of the axis. So
Correct.
we can directly, like add them by removing the minus sign. I believe we do that
Yes.
as well.
So there is something called what I can say, mean deviation. There is something statistic that is called mean deviation. In the mean deviation, what we do is very good question. Let's just try to understand this. Okay, try to understand the analogy behind it. The mean deviation is nothing but you remove the negative and positive values and make them absolute. Okay, or it is called absolute mean deviation. Okay, and you just take absolute values average, and you define your standard deviation on that behalf. Okay, now why statisticians, that is also one way of doing it, but why statisticians prefer standard deviation in square terms? Because try to understand this, as you go away from the mean, now listen to me very carefully, as you go away from the mean, okay, the distance is more, the square of the greater distance is even more. Are you understanding? So this is amplifying the distance. As you are going away, the result is getting amplified more. Are you understanding? How many of you have understood this? Just type yes. As you are going away from the mean, the square value is amplifying more and more and more. And that what statisticians are preferring over the absolute value. Okay, because the outlier here in the standard deviation formula will get more weightage and will get more, more value rather than the absolute value. Are you understanding? It's a good question, by the way, Mr. Paul. So there is something called absolute standard deviation. Okay, and sorry, absolute mean deviation, not standard deviation, absolute mean deviation, which the formula which you suggested, that remove the negative and positive sign and just take the values and take the average. That's called absolute. But why statisticians have not preferred absolute value? Because it is not giving the weightage to the extreme values. Okay, as we are going away from the mean, the square values are giving the weightage of the extreme values. Okay, clear, huh? Yes, everybody clear about this? This is a very good question he has asked. Anybody not understood this? Just type me in the chat box. Even if you're not understood, it's okay for if you're not understood. Okay, हमारे statistician लोगों ने, they have taken care of this. So we just have to follow this formula, but we should know why they have taken the squared value of this. Okay, why they have taken, because as we are going away from the mean, okay, the square values are getting, okay, there are a couple of people who have not understood it. Very good, fantastic, very good. Let me just quickly explain this. Even if we have not understood, it's okay. Okay, now let's understand this. Now, as we are going away, let's try to understand. Our average was 172.6. The people who have not understood this. Okay. Average is 172.6. Just type yes in the chat box. Yes. Median का बाद में बताऊंगा. Okay, try to understand this. Average is 172.6. Yes, clear है. Now let's try to understand this. There is one value which is very close, which is 1.6 centimeter. Okay, there is one value which is value number 3, which is very close from the average, right? Only 1.6 centimeter away from the average. Clear hai? Just type yes. Just type yes. Just type yes. Okay. Now there is one value which is 11.4, very farther away from the average. So there is one value which is very close, one value which is very away from this. Are you understanding? As see, standard deviation, we are understanding, we are measuring the variability. Okay. Now variation may, as the variation is high, okay, it is not good for our process. Correct? So what standard deviation formula does, it basically gives more weightage. Now tell me one thing, 11.4 ka average square kitna hai? It will be more than 100, more than 120. Correct? 11 ka square, 11.4, it will be 130, something like that. Correct? What will be the square value of 1.6? It will be very close to 1 or 2. Are you understanding? See the difference we are getting. The two values which are the distance only. See if I do the square of this value 11.6, can you just calculate the square of this value? The value which is farther from the mean, what is the square of 11.4? Just can you just tell me 11.4 ka square kya hai? 11.4 ka. What is the square of 11.4? 120? 129, right? Yeah, 120. So very close to 130. Can you see this? Very close to 130. Okay. And what is the square of 1.6 or minus 1.6, which is 2.6? Can you understand this? See how it is getting amplified. As we are going away from the mean, the values are getting amplified. Are you understanding? As we are closer, the value is very less. As we are going a little away, the value is getting amplified. It is like this, spreading the wings. Are you understanding? Just type yes in the chat box. The people who have not understood it. That's why people wanted that variability, okay, should get amplified in the standard deviation. Because we are measuring the standard deviation, the variation should get amplified. And that was the reason they have gone for the squared value rather than going for absolute mean deviation. Okay. As Mr. Paul, what you can say, suggested, there was also option available for the statistician. But they wanted to get this amplification as we are going away from the mean. Okay. So from the mean as we are going, so this squared value is actually denotation of that amplification. Clear hai? Just type yes. Everybody, the people who are clear till now, clear? Yes. Yeah. Now, why I've just broken down into pieces, because you should understand where this formula is derived. Okay. Now onwards, you can easily derive the standard deviation formula as well. But manually, it will not be needed anytime. Okay, because manually we will never have only 5 data points. We will have 100, 500, 3,000 data points, and we have to calculate standard deviation, and we have to quickly take the decision. Okay, but how this formula is derived, we need to clearly understand. Okay, till now, so far so good. Just type yes in the chat box. So far so good. Just type yes, 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 yes. Everybody, clear hai? Yes. So you can calculate standard deviation very easily. Superb. Okay, now let me just give you another analogy of why this is important for us to calculate this. Okay, let me just clear this off. I hope you guys are taking the notes along with me, right? Yes, Professor. Okay, yes. Okay, are you taking the notes along with me? Just type yes in the chat box. If not, then please do that, because then it will, you will be more clearer. If you are taking the notes, you will be completely focused in the subject as well. You will not deviate, and you will understand the topic. Okay. Yes. Very good. Very nice. Fantastic. So let me quickly give you the analogy. Why this is important. Why this is important. Okay. Now I have already given you this. Now try to understand one simple analogy. Okay. Now let's try to find out. We have a data of the height. Okay. The target, for example, is target height is 1 170 centimeter. Okay, for example, target is 170 centimeter, USL is 180 centimeter, and LSL is 160 centimeter. Okay, so this is LSL and this is USL. Now, let's say there is a recruitment of army is going on. Just try to understand it. There is a recruitment of army is going on. They want people from height 160 to 180 only because of some specific reason. Okay, maybe because of some special task force. Okay, they want people between height of 160 and 180. Now, anybody who is away from this, okay, anybody who will be away from this will be, so let's say somebody is 158, okay, sorry, 158. So he will fall here. So his height will come here. So he will be rejected. He will be rejected. Or somebody even, more than 180, let's say 184, like Mr. Divakara was today. Okay. So in this particular platoon, he will not be selected. Maybe in a different platoon, he will be selected. So this also will be rejected. Only 180 and 160 will be selected. Are you understanding? Just type yes in the chat box. Why we are taking the data and we are just spreading the data across. So if I collect the data like this and give this, okay, I will find out a histogram. And if the people who are above and below this will be rejected, the people within the band will be selected. Okay. Now try to understand this. Now just try to understand this. If I collect the data, now there are some assumptions we are making. Okay. And I collect the standard deviation. What was the standard deviation? We have collected the standard deviation for the data. What we have collected, it was 6.59, right? Something like that. 6.59 centimeter was the standard deviation. Clear hai everybody? Yes, we calculated with this, the formula which we derived, 6.59, correct? Just type yes, you know that, right? How we have derived it. Okay, imagine for a different data set, okay, for a different data set, the standard deviation is 5. Standard deviation is what? 5 centimeter. Okay, for a different data set, I have collected more data and standard deviation is 5 centimeter from the mean. How do I read standard deviation? Meaning from the mean value, okay, 5 centimeter, average deviation is 5 centimeter. From the mean value, average deviation is 5 centimeter. That is how I can read the standard deviation in the layman's language. Okay, now understand this. There is something called a Z value. Something called a Z value. The formula of Z is, okay, USL minus X bar divided by standard deviation. In this case, our USL is equal to 180. Imagine our mean is exactly 170. Okay. Our X bar equals to 170 and our sigma, our standard deviation is 5 centimeter. Okay. So 180 centimeter is my upper specification limit. 170 centimeter is my mean. And my standard deviation is 5 centimeter. Can you calculate Z for me? Can you just calculate Z? Just type Z in the chat box. Calculate the Z and give me the answer. 2. Everybody clear? 180 minus 170, which is 10. 180 minus 170 divided by 5, right? So 10 divided by 5 is equal to 2. Clear, everybody? Just type yes in the chat box. Everybody clear about this? Right? So in this process, the sigma level, so this process is called a 2 sigma process. This process, when the Z score is 2, this process is called 2 sigma process. What does it mean? I can fit, try to understand this, because my standard deviation is 5 centimeter, just see here. So I can fit 2 times standard deviation here. 1 standard deviation, because this is 5 centimeter, and this is second standard deviation of 5 centimeter. So I can fit 2 times standard deviation between 170 and 180. Try to understand this. Between my mean value, I am assuming 2 things here. My assumption is my target and my mean is equal. Understand this. My target and my mean is equal. That is my first assumption. And my standard deviation is 5 centimeters. Okay. In that case, I can fit Yeah.
9:30 नंतर पद्धतीने
Madhuri, are you asking me or
मला क्लास
no? No. Okay. I think she got
इतका वेळ केलंस ते
she got unmuted and she's not aware of this. Okay. Anyway, right. So are you understanding? Between 170 and 180 on the one side of the specification, I can fit 5 and 5. Between 10 centimeter, I can fit 2 standard deviation. Can you see here? So 1 sigma here, 1 sigma and second sigma. That's what I can fit 2 standard deviation. It is called a 2 sigma process. Are you clear? Just type yes in the chat box. Are you clear? Between USL and H bar, I can fit 2 standard deviation of 5 centimeter each. Correct? 5 and 5. So between 170 to 175, I can fit 1 standard deviation. From 175 to 180, I can fit another standard deviation. Clear? So 2 sigma I can fit. So if I can fit 2 sigma, it is called 2 sigma process. If I can fit 2 sigma, it is called 2 sigma process. Now imagine my process is like this. Okay. And my standard. Now, if my process is narrower, I just imagine. Nilesh, this is imagination. Thoda imagination ke liye. Okay. 5.96 thoda calculation is difficult. I have just rounded up to 5. Simple. Okay, nothing else. Now if my variation is reduced, my sigma will reduce. This number will reduce or increase. If my process is narrowed down, my standard deviation will reduce or increase. It will decrease. Yes, it will decrease. Correct? Very nice. Fantastic. Are you clear with this? As my process coming closer, my standard deviation is reducing. As my process is going, what you can say, away from my mean, my standard deviation will increase. Are you understanding? Okay. So let's say this is my process number 2. This is my process number 2. Okay. Now imagine my process number 2 is having the standard deviation of 2.5 centimeters. It is very less.
Hello.
Yes,
Hello?
Mr. Nagappa, tell me.
I have one doubt here. We have
Anji.
taken LSL minus X bar divided by sigma G value. Instead of that, we can check USL minus X bar divided by sigma for the G value.
You can take this side as well. You can take on this side as well, both sides. I am assuming that it is in the center.
Both should not be a same. Both should not be a same. We have to take bigger one or smaller one. G value.
No. What I'm saying is, we are right now assuming, just to understand the concept, we are assuming my mean is exactly at my target, exactly at the center. That is my assumption. That's what I said. There are 2 assumptions.
Correct.
One is my mean is exactly hitting my target. Okay. So in this case, you can take either LSL or USL. Any side you can take, both will be equal. Clear hai? Yes? You can fit 2 standard deviation on each side. Okay. USL may be 2 kar sakte hai, LSL may be 2 kar sakte hai. Are you clear? Have you understood?
If it is shifted to if it is shifted to other side.
So let's not get confused right now. Okay, let's stick to this very basic fundamental. Pehle fundamental clear kar le. Clear hai? Yes.
Okay.
Both are equidistant from each other. Okay. We are at the exact center. Both USL and LSL are equidistant from each other. Clear? Yes.
Clear.
Yes. Very good. Now try to understand this. Now you calculate this. If my sigma, if I have the I have the less variation process, my standard deviation is 2.5. Can you calculate a Z value right now? Can you calculate Z value? With this same formula, can you calculate? Now USL minus X bar will remain same. USL is 180, X bar is 170. Okay, my sigma will change. My sigma will become, instead of 5, it will become 2.5. Right? So 10 divided by 2.5 becomes 4 sigma. 4, right? So the moment my Z score is 4, this is called a 4 sigma process. Are you clear? Now I can fit 2.5, 2.5, 2.5, 2.5. I can fit 4 standard deviation between my mean and my upper specification limit. So I can fit 4 standard deviation, right? I can fit 4 standard deviation. So my process is 4 sigma process. Clear? Yes, I will repeat 100 times. How many of you are clear? Just type clear in the chat box. How many of you clear with this? Just type yes in the chat box. Clear hai? Super clear? Okay. Yes. Before I repeat, let me just, okay. So a lot of people are clear. I think there are 1 or 2 people who are not clear. I will repeat. Okay. Try to understand this. So we have first step, we have calculated standard deviation. Sigma calculation we have understood. Okay. Now there is a process. Now we are calculating how much process is capable. Okay. The Z value is basically defining how capable is our process. Okay. The Z value is nothing but how capable our process is. Now, what are we doing? The formula is USL minus X bar divided by standard deviation. Okay, this is the formula. Okay, now you just put the values over here. USL is 180, right? Yes, Mr. Abhi, just try to understand. USL is 180, X bar is 170, and my sigma is 2.5. Okay, sigma is 2.5. Now just put that in the formula. You will get 180 minus 170, USL minus X bar, okay, which is 10. Okay, 180 minus 170 is 10, divided by sigma is 2.5. So 10 divided by 2.5 becomes 4. So 4 is my answer. So when my Z score is 4, so that process is called 4 sigma process. Yes, sigma I have assumed. Yes, very good. Yes, sigma I have assumed. Just to give you this Z value calculation. Okay, because sigma calculation we have already studied. For the right data, we can calculate sigma. Now I'm just calculating Z value. Now I'm correlating why this standard deviation is very important. Okay, are you clear? So if I can fit 4 standard deviation between my mean, this is my mean value, and between 170 and 180, I can fit 2.5, 2.5, 2.5, 2.5. Can you understand this? Between 170 and 180, I can fit 2.5, 2.5, 2.5, 2.5. 4 times 2.5 I can fit. The moment I can fit 4 times standard deviation, this process is called 4 sigma process. Clear hai? Mr. Abhik, are you clear with this? Okay, if I can fit 6 times, okay. Now, if I can fit 6 times, what this process will be called? If I can fit 6 times, it will be called as? Exactly. Yes, what is the need of standard? What is the zero? Yes, I'm coming to that. Okay, very good, very good. Okay, now just try to understand this. When I say this, when I say 2 sigma process, okay, 2 sigma process, this 2 is called Z value, and this sigma is called standard deviation. When I say 6 sigma, the value 6 is the Z value. Now, Z is what? What is Z? Z is nothing but our process capability. Write this down. Z value is our process capability value. Process capability. Okay. So, one value is defining our process capability, and second value, the sigma, is defining our standard deviation, our variation. Okay, try to understand this. So let me write this down. If I have the space here, let me remove some of the earlier content. Okay, try to understand once again here. When I say 6 sigma process, this is a Z value, and this is the standard deviation value. Okay, our role is to reduce standard deviation. Our role is to reduce standard deviation. No, just try to understand this. Just type yes. Our role is to reduce standard deviation. Sigma को कम करना है, standard deviation को कम करना है. Yes, just type yes in the chat box. Okay. As we are reducing our standard deviation, we are increasing our process capability. So, as we are reducing our standard deviation, our process capability from 2 sigma, it will go to 4 sigma. From 4 sigma, it will go to 6 sigma. As this is dropping down, this will go up. This Z score will go up, and that's what we want. And that's why we are doing the projects. Are you understanding this? Yes, exactly. See, whatever we want to improve, we have to measure it, right? Now, see, measuring the variation is a very tricky affair. Try to understand this. And statisticians have found out the answer to that, which is nothing but the standard deviation. Standard deviation is the measure of the variation. They have found that they have decoded this. They have found the answer to variation is a very complex topic. It's very difficult to measure the variation, right? Because in various contexts, the variation is very much what you can say, a little tricky affair, right? So they have simplified this with this standard deviation formula. So we calculate a standard deviation, okay? And then we calculate what is our process capability. Now answer this question. Okay? Now answer this question. If I give you the data set, only data set, what is data set? If I start the process and I collect the data, can I calculate sigma from the data set? Can I calculate sigma? Just type answer in the chat box. Can I calculate yes or no? If I collect it, I start the machine and collect the data. Can I calculate standard deviation? Just type yes or no. Very good. Can I calculate z value with the same data? Can I calculate a z value? Just type yes or no in the chat box. With the same data, can I calculate a z value? Okay. Now, with the same data set, the data set is there. I can calculate the standard deviation with the data set. But exactly, Parvinder ji, you have hit the nail. I cannot calculate the z-score unless and until I know specification limits. Are you understanding this? Are you understanding? Just type yes in the chat box. This is the deviation. So deviation you can anywhere calculate from any data set. But if you want to calculate capability, process capability, you should know what customer want. No. If customer requirement are not understood, you will not be able to understand whether I'm capable or not. Are you understanding? Just type yes in the chat box. So to calculate the capability, you want specification limit. Okay, you can draw the histogram. Okay, let's do this. Let's do this on Minitab. Have you understood till now? Just type yes in the chat box. Type yes in the chat box. Have you understood this? Yes. Very good. Fantastic. Now let's go to Minitab. And just do this exercise. Okay. Now you will correlate with this very easily. Okay. So I've just opened okay. So now I am writing the same height of the data set. Okay. And I'm randomly putting some data. Okay. Okay. 120 centimeters. Okay. 170 centimeters. 168 centimeters. 155 centimeters. You have, 119 centimeters. There is somebody 186 centimeters. There is somebody 165 centimeters, 170 centimeters, okay, 147 centimeters, and so on and so forth. Okay, so we have the data. So I've randomly collected the data. Now, what I will do, I can find out the mean. Okay, mean, everything, all these aspects I can find out. Let's go for a graphical summary, which will summarize everything, which will give us a histogram, which will give us what is the mean, variation, everything. Okay, let's go for the graphical summary for this. I just select height and I say, okay. I just randomly selected any data point. Okay, look at this. So data looks like this. So data looks like what? This. Okay. So try to understand this. What is my mean value here? Mean is 155.56. Can you see here mean value 155.56, which means the average height of the data set is 155.56 centimeters. Are you clear? Just type clear in the chat box. See this. Are you clear? 155.56. Clear hai? Just type clear. Everybody. Clear hai? Okay. Yes. Now this is called sigma, standard deviation. Can you find sigma standard deviation? 23.08. 23.08 is our sigma standard deviation from the mean, from 155 centimeters. Okay. On an average, we have 23.08, distance, average distance from each and every data point is 23.08. Are you clear? Yes. Are you clear? Now, do we have the Z value here? Do we have the Z value here? Can you find Z value in the table? Z value hai kya yahan pe? Just type your answer. Yes or no? Do we have Z value? No. Why we don't have Z value? We have only data. We have calculated standard deviation, mean, variance, because from the data we can calculate all these things. Okay. To find out the Z value, what do we need? What do we need? Yes. Specification limit. Exactly. Fantastic. Very good. So to find out the capability of the process, we want specification limit. Okay. So what we do, we go to stat, quality tools. Okay. And what we'll do, we will find out the Z value. Okay. Imagine this is a normal distribution. Is it a normal distribution data? Is it a normal distribution data? Just now, senior people should answer this. Okay. I will not answer this. Is it normal distribution data? Is the data normal distributed? Just type yes or no in the chat box. No, no, no. Okay. Yes. Okay. Somebody said yes as well. Okay. No. Okay. A lot of people are saying no. Very good. Very good. Can you see here Anderson-Darling normality test and p-value is 0.144? Try to understand this. If this value of Anderson-Darling normality test, the p-value is greater than 0.05, write this down. If this p-value is greater than 0.05, this is normal distribution. Yes. Yes, I'm not going into p-value because then it will go to 11 o'clock today. Okay, I will not go to p-value, but this is just for your understanding. Okay, if this p-value is greater than 0.05, the data is normally distributed. Okay, just for your understanding, we will discuss this sometime later. Okay, but now I want to find out the Z value. How will I find out? I will go to stat, quality tools, capability analysis, normal. Okay, just take a screenshot of this. Stat, quality tools, capability analysis, normal, because the data is normally distributed. And I will click on that. Okay. So the data height is in there, single column. Subgroup size, there is no subgroup because individual data points are there. Now we will put lower specification limit at 150 centimeters and upper specification limit at 170 centimeters, for example. Okay, I'm just giving you a lower and upper randomly. I'm just giving just for your understanding. Okay, and I will go to option, and here you can see Z value, benchmark Z value. I will just click over here in option, and I will say okay, and I will say okay. Yes, and abracadabra, we have the Z score here, which is minus